Dear students, today we are going to discuss algebra of derivable functions. You know that derivable function is that function whose derivative exists at each and every point of its domain. Let f and g be two derivable functions, that is, derivative of these two functions exists over their domain. Then the first is derivative of some function or the subtract function, that is d by dx of f plus minus g is simply difference or sum of the differentials, that is d by dx of f of x plus minus d by dx of g of x. Similarly, if we have the quotient function, that is fx upon gx, then its derivative is simply a denominator square. Now denominator into differentiation of numerator, that is f of x is here numerator, minus f of x minus numerator into differentiation, that is d by dx of a denominator, that is g of x, provided this g of x is not equals to 0, or simply we can say that this g is a derivable function. Now this is called as the quotient rule of differentiation. So simply we can say that if we have a quotient of two functions, that is f by g, then its differentiation is simply equals to, in a numerator, it is first denominator into differentiation of numerator, that is first minus numerator into differentiation of a denominator upon a denominator square. Similarly, if we have the product of two functions, that is fx gx, then its derivative is simply first function, that is g of x, into differentiation of second d by dx of g of x plus g of x d by dx of f of x means first function. This rule is called as simply the product rule. Product rule or the quotient rule, which you studied in class 11th. Now today we are going to discuss derivatives of the composite function, derivatives of the how to find derivative of a composite function. Now if we have two functions u of x and v of x, such that there is another function f of x which equals to the composition of these two functions, that is u of v of x, that is f of x is simply the composition of these two functions, then this function f of x is called as the composite function, which means that function which is equals to the composition of two given functions. Now how to find, now the question arises, how to find the derivative of this very function which equals to simply the composition of two functions, that is here we have to find this f dash of x, or simply d by dx of f of x. Now here f of x is u of v of x, such that u of x and v of x means individual functions are derivable, that is derivative of these two functions exists at each and every point, that is u dash of x and v dash of x exists. Now if we put t equals to v of x, because u of v of x is simply u of v of x, because how to define the composition of two functions. Now if we put t equals to v of x, here v of x is derivable at each and every point, which implies that derivative of this with respect to x exists. Hence, by differentiating first, it is dt by dx is v dash of x. Also, u is differentiable, which implies that du by dt also exists. Now here a given function is f of x, which is u of v of x, which can be written as u of v of x, which is simply v of x is t, that is u of t. Now which implies that f of x is simply u of t, where t is given by this first, that is it is a new variable here. When we differentiate this f with respect to x, now in LHS we simply get d by dx of f of x. But here this u, there is a parameter t. This means that here we have to differentiate this u with respect to t. It is du by dt, because u is the function of t. Also here from first t is connected by x, which implies that we have to differentiate again this t with respect to x. it is dt by dx, which implies that it is simply d by df of dx is simply du by dt into dt by dx, where dt by dx is simply v dash of x because from first, which implies that uh, df by dx is simply du by dt into dt by dx into dt by dx, where dx is given by v dash of x. This rule is simply called as the chain rule of differentiation. So what is chain rule? Chain rule is simply that rule which gives us the differentiation, or which gives us the derivative of composite functions. Now if we consider a function which equals to the composition of three functions, then its differentiation is simply, here we have in first we have a function which is f, which is equals to composition of two functions. So this means that here we are using new variable, only one new variable. Now if we consider here function u of v of w, then df by dx is simply, here we have three functions, so we are going to use here two dependent variables, that is du by ds, ds by dt, and dt by dx, where t equals to w of x and s equals to v of t. This is called as the chain rule of differentiation. Similarly, you can continue this up to finite number of functions. Now if we consider a function sin x square, now if we put v of x is x square and u of x is sin x, then clearly the sin x square is composition of these two functions, that is v of x. So by chain rule, if we put t equals to v of x, that is x square, which implies that dt by dx, it is simply 2x. It is 2x. Now ut is sin t. This means that du by dt is cos t. Cos t. You know that differentiation of two functions which are connected through composition is df by dx is du by dt into dt by dx, which is simply du by dt is cos t, because it is cos t, and dt by dx is 2x. But t is x square, which implies that df by dx is simply cos x square, because by putting t equals to x square, it is cos x square into 2x, or 2x cos x square. Now if we consider another example, f of x equals to sec of tan root x. Here it is the composition of three functions, one the sec, second tan, third root x. Now if we put last one equals to w of x equals to root x, v of x equals to tan x, and u of x equals to sec x, then clearly this f of x, that is sec of tan root x, is simply composition of these three functions, that is u, v, or w of x, that is sec of tan of root x. Now if we put t equals to root x, because the last one, which is w of x, it is dt by dx is 1 by 2 root x. Now s equals to second, that is s of t, s equals to tan of t, which implies that ds by dt is simply sec square t, sec square t. Hence putting the all such values in f, it is f of x is sec of s. Now differentiating this f with respect to x, it is df by dx is d by sec of ds minus into ds by dt, but again t is connected with x. This means that we have to multiply dt by dx. Why this is of this type? It is df by dx is simply because by cancelling ds by ds in numerator and denominator, by cancelling dt by dt in numerator and denominator, so we simply get d sec means df by dx. Now d sec by dx is sec x, sec s tan s, because differentiation of sec with respect to x is sec x tan x, while as differentiation of sec with respect to s is sec s tan s. Now ds by dt is sec square t, and this dt by dx is 1 by root 2x, 1 by root 2x. Now replacing back this t with respect to x, t is here root x, so this means that tan of tan, and s is tan t. This means that simply s equals to tan root x. So by putting all such values, we simply get sec of tan root x into tan of tan root x plus sec square root x plus 1 by 2 root x. So this is the differentiation of this sec of tan root x. Now second one is sin of sin x into cos x cube. Now clearly here, this, if we put f of x equals to, if we put here f of x equals to sin x cos x square, sin x into cos x square, this means that this f is the product of two functions. So by using the product rule of differentiation, we stated that if we have two functions, then its differentiation is first function into differentiation of second plus second into differentiation of first. Here first is sin and second is cos x square, so it is first into differentiation of second, that is d by dx of cos x square, plus second, that is cos x square into d by dx of sin x. Now differentiation of here sin is cos simply, but we don't know differentiation of cos x square. So from, we can write this as d by dx of f of x sin x into d by dx of cos x square plus cos x square into sin x. Name it first. Here cos x square is product in the composition of two functions, one the cos x, second one x square. So by using chain rule, differentiation of simply cos x square is minus 2x sin x square, because if we put, suppose, new f dash of x, or simply f1 of x equals to cos x square, then this this new function, that is cos x square, is simply cos of x square, cos x composition of x square. So using chain rule, you can simply find its derivative as minus 2x sin x square. So from first, or put this value in first, d by dx of f of x is simply sine of differentiation of cos x square, which is minus 2x sin x square plus cos x square sin x. Or simply we can write this as minus 2x sin x square plus sin x cos x square. So this is the required differentiation or the derivative of this function, which is the product of two functions, and the later function, that is cos x square, is the composition of two functions. So here we are using two rules, one the product and second one the chain rule of differentiation. So thank you.